All right, there we go. We're up and running. Welcome to another class of CS202. So, last time we talked to you about the concepts of object-oriented programming, a class, UML diagrams, and constructors, destructors, encapsulation, the abstraction, and public, protected, and private, although we did not talk about protected much because we haven't talked about derived classes and inheritance, which maybe we'll talk about at the end of today or next class. And I think that was pretty much it, right? Oh, I talked to you about the syntax of how to declare a class, I suppose, and class versus a struct and the differences there and whatnot, and so on, right? And I think that's pretty much all we talked about in last class. However, we didn't really show you code. I mean, well, we show you a little bit of code, but we had this idea of this car class that we wanted to go ahead and implement as a actual example, like a nice and beefy example of like all of these concepts basically put together, right? Now, I thought of the car class, but if anybody has a better idea, now's your chance. Otherwise, we'll just go with this car class, okay? So, yeah, okay. I don't see any immediate ideas, so we'll just do the car then. Dice class. Well, dice is too simple because like you just throw the dice and you roll it, and like what else can you do with the dice though? So, yeah. Or if it's already an assignment, then not. I don't want to confuse you with doing something. So I guess, I was thinking of doing plane, but I think I did plane like last semester, so I don't want to do plane again. So I guess a little depressing, but we'll do a car. Can't think of anything else right now. I mean, like something interesting that would appeal, but what else could we do with a car? What about spaceship? We do a spaceship. That would be a little more interesting. Like let's do a Star Wars spaceship or something. Something that's more exciting. And it has the same sort of things as a car, so it could work out. Pets, like we're doing one of those like Chibo or whatever those things were called, the little toy pet things. Okay, yeah, I like that. Let's do that. Let's do the pet thing. Let's do the pet thing. Remember those things? Like I mean, I probably don't remember them. Wasn't really a fan, but they were like when I was a kid. They get little calculated looking devices where you kept the digital pet, and if you didn't feed it, it would die. I forgot what they were called. Yeah, Tamagotchi. Yeah, that's probably it. Tamagotchi or whatever. Okay, yeah. So let's just do that. That's actually a good one. Okay, and then we don't run into like copyright. Well, that's probably copyright, right? Yeah. Okay. So I don't know which of the two spellings it is. Let's just go with the second one, because I think that sounds more correct. So this Tamagotchi that we're gonna make, we want to do the UML diagram for it before we start coding. So let us go ahead and do that. Okay. So let's think about what features we want to have in our program. And by the way, we don't have to call it Tamagotchi. Maybe for copyright reasons, let's call it we call it something else, we call it like the Tamagotchi or something. I don't know, but whatever. I don't think we're gonna get sued by them. Okay, so what do we want it to do? What do we want it to do? Well, okay, again, I hope that you guys remember better than I do, but I think some of the things that it had was to feed it. Right? We needed to feed it. And so here, let's just put these as bullet points first. So we want to be able to feed it, to sleep. It needs to be able to keep track of time, because so that it knows when to eat and things like that. What else do we want it to do? What else did it do? I don't really remember. Play with it, maybe? Like an activity to play. And then maybe to die. Or be born. Die. Function to die. Okay. Yeah. Okay, I think that's good enough. in terms of activities. Yes. What information should it keep then? Well, it needs to be able to keep the time, like we were saying. It needs to keep its status, I suppose, if it's alive. Maybe what else do we want to? Health, okay, like a HP, health points. Hunger status, yeah, I like that one. Hunger status. Okay, I think that, I mean that's good enough for now. We can add more things as we see fit, but I think that's a good starting point. Okay, so we have what it wants to do and what kind of information it wants to keep. So let's go ahead and define what our classes are going to be and what our class functions and class variables are going to be and whatnot. Okay, so it'll be easier to start off with the functions, and we're probably going to need more space than this, but we'll go with that. Okay. So we want to make a feed function, so where you can just call it like feed, and we make it a public function so that you can call it from your client code, and it's a void function because you don't really need to return nothing out of that. Okay. We also want to find out whether it's alive or not, so maybe live status. And that does not return an integer, but maybe that returns a Boolean, which is true or false. Or maybe we should call it is alive. Okay. What else do we want to find out? Maybe get the time, get current time. So that could be useful. Maybe that returns a TimeT or whatever the class is at Linux time. I'll have to figure out what it's called. TimeT, I think it's called. And then maybe we want to be able to return some of these things like get HP, which returns, let's just say, an integer. And then need more space. How do I modify? There we go. Okay, that's not cooperating at all. Let's make a new rectangle. Oh, okay. Hold on. There we go. Update HP. Yeah, let's do an update HP, but let's make that private because we don't want people to like hack in and change the HP. So update HP, it's going to take an integer and it's going to be a void function. We'll be able to work with user interfaces so we can actually draw the pet and have it on screen. Not in 202, other than the ncurses library, maybe. Like whenever I made all the assignments for my class, we made like a battle royale game, but it was still terminal based, and we use ncurses to render the screen. And in 302, I'm making them do a CS:GO clone, but it's still terminal based, like top view 2D game, and it's still just a bunch of ASCII that's being printed. So we don't necessarily hook up with like Unity or an engine, or like what's called OpenGL to actually render stuff. Maybe in 218, I think Ed might hook it up some things with OpenGL, so we might see that there. So yeah, I'm curious what they do in 202 though. In the EGG 202 you're talking about, what do they use for that? Do they use a special library or something? WinForm? I don't know. If I can come up with, I mean, not really for 202 because of the code grade stuff, but for 302, it would be cool for me to use some engine. The problem is, like, I would love to be like, yo guys, install Unity so that we can write some code for it. But A, Unity's in C#, and B, it's Unity and people might not be able to run it and it'd be a pain. So, yeah. So, we make do with what we can. But yeah. Anyways, let's see, update HP, hunger status, we have the feed function, but we might want to be able to get the actual status. So like is hungry could be useful. And then I think that's enough for those getters. To be able to go to, we don't really have any status for the sleep stuff. Maybe we won't add that in right now, just because this might become like super. I want to be able to finish this within the allotted class time. So let's just put those in for now. In terms of variables, though, let's put the variables in. So we want them to be probably private, all of them, and we want things like HP. Although we are going to make it lowercase. HP is going to be an integer. We're just make whole numbers for the HP. Hunger status. Hunger stat is going to be a Boolean. And then is alive is a Boolean. You know, we could actually call the hunger variable is hungry. I think that's a better code if we do that. Like that. And then time.t to be able to keep time. Okay. I don't know if that has to be a class variable because we might import it, but I'll put it in there. And you know, Java is a lot like C#, and you're going to be using Java in 226. So have fun with that. But C# is not too bad though. Okay, that's good enough for now. All right. So now what we're going to do is we are going to attempt to actually make. This was the thing I had set up in the past, but I don't know if it's going to be easy to set up now. Yeah, kind of worked. I got to move things around though, but we're going to keep that on the side so that we can see it as we code. Although I got to move that or something, so hold on. How about that? It's not super small, but you know, at least it'll be good for reference. Actually, you know what? I should really move this a little bit like that. So you can take full advantage of the coding space like this. And then like that. Okay. Just trying to like optimize the space. And then we'll put this here like this, okay? All right, I make do as I can. Okay, all right, so let us begin to code. Make sure the compiler still runs, F5. Okay, still runs, good. And I am not gonna do the splitting of the header and the CPP file stuff because that's just like, I would have to modify the debugger for that to work. But you can watch one of the older videos where I think I do that in the summer. Okay, so I don't think we need that included, but let's leave it in there anyways. You're gonna have to keep track of me if I go off the screen, but I don't think I should because everything is here. In fact, maybe before we code, we're gonna shrink this a little bit more so we get as much space as possible, okay? So let us start with our class. Go, what did we say? Gochi like that? Okay. Class, and by the way, when we do inheritance next week or at the end of class, I think we'll just modify this example too. Add like Tamagotchi v2 or something, okay? So, bam, we just created our class, we're done, right? We can move on. Okay, let us go ahead and throw in all our variables. So let's do int HP is hungry is a bool. Bool is hungry. Then we got it's alive. Bool is alive. And then the time.t stuff, I gotta check that on Google. I gotta remember how to import that. TimeT C++. TimeT CPP reference. There we go. Okay, so the header for that, here, let me post the link for that, is this. So when you include time H like this, and I think that that will be good to go, okay? So let us try that and hope for the best. Oh, here, let me move this here, it'll be easier. Right now, because I'm using that to go. Yeah, okay. The reason why I'm importing this time.h stuff is because I don't want to have to write code to keep track of the real time. Like, I just want somebody else to do that for me. And so that's what I'm going to do. All right. So in fact, before we even mess with it here, let's just do a quick test run. Ooh, I forgot to put the namespace stuff up there. Although we're not really using the namespace so far, but we might later if we do some C outing or whatever. So let's say time T, I think it's null. No, wait, that's for like srand. Let's see what documentation says. Time T epoch. Time since epoch. No. What's the variable for Linux time? Time. Oh, it's just time. Okay. Let's see if that works. See out time and line. I don't think that's gonna work, but maybe it will. We got a 1 out of that. Very cool. Internet. Very cool. It's a function, that's why. What? See. Time. STD time. No. So it was time null. So I guess I was right earlier. My apologies for that. So it should be time null. Ah, here we go. Great. Okay, now it worked. So what this number is, by the way, if you're not aware of, is like when it comes to computing and you're trying to synchronize different computers to work together, it makes sense to have some sort of like time for that, right? There's too many time zones and different ways of measuring time in the world. And so in the 1970s, they basically said, okay, let's just like use a counter for time. And that counter has to start somewhere because we need time 0 for that to work, right? And we can't make time 0 be like if you go from like the religious point of view and make it like, oh, it's going to be 0 BC or something. That's too far back in time to like cause headaches and whatnot in terms of time. And we don't need that. We just need like time from now. So they just said, we're going to make the first second of 1970 to be time 0. And I think that's what they use as the epoch. And so, yeah, currently this many seconds have gone by since 1970. If I refresh it by running it again, you'll see that the number is bigger. This is the only time in your life you'll get to see this number, because if you run it again, now we get a different number. And this was a big issue because like integers can only run up to 2 billion, right? 2 point something billion, 2.4 I think. And so like, as you can see, we're already at the 1.6 billion. So we're getting close to that like number end. And so like, so if you want to get a time before 1970 is negative, no, they just don't use this system for that. But most calendars, I think, don't let you go before 1970. Like they have to use a different system for that. But anyway, this was like oversimplification of the times, I think. But yeah, when it gets to 2.3 billion, you're in a problem because it's going to reset to 70. So it's going to be like a 2yk thing again, all over again, right? So what they're doing now to fix that is they're making it a long int. That will solve you for a long enough time. But we got to upgrade all the old computers that are still using the old system, right? So 2yk is happening again, that kind of thing, okay? So anyways, that's enough story time about that. However, this, of course, is still just a number, which I don't like. So let's just see how we can make that print prettier. I believe based on here, let me tell you what I'm looking at now, because that first link was like kind of not very nice. This one is nicer. We use ASC time for that, I think. Let's see if that will work. So here, let's leave that in there, and let's put a C out beneath it. It's going to be ASC time. Let's see, ASC time. And then we put this in parentheses, apparently. Actually, here, hold on. Let's make this a current time, and then that gets time null. So that's just going to get in the integer representing the current time. And then we're going to print that out. And so now let's try to print that out in a more human looking way. Okay? So this says that there's a function called ASC time where you pass in the local time and you pass in by reference the current time. And maybe that'll work. I highly doubt we're going to get this working the first time. Nope, didn't work. Can I convert int to constant time? Okay, let's make this a constant. Can I convert constant time to constant time t? Ugh, okay. Let's make this a time variable then. Time t. Okay. Yay, this worked. Great. So to summarize the errors that I ran into was that I tried to store that Linux number as an integer, but the function expects it to keep it in the same class that TimeT is at, and it was yelling at me for that. So I just made a TimeT variable, which is why when I wrote this earlier here, I put that TimeT thing. So I guess we're gonna have to keep it like that. But anyways, after all of that is said and done, we get nice little time thing there that looks humanly readable. Okay? So sorry, I haven't used TimeT in C++ in a while, so yeah, I kind of remembered it, but not enough to just flat out put it in. But yep. Well, it's not. By the way, this is not a C++ thing. This Linux time is like all Linux, like all Linux systems. So like whether or not you're using C++. So like you go to like an old computer from like 10 years ago, whether it's using C++ or not, I guarantee you that it's using the Linux time into like this integer. And so bad things will happen. Although, by the way, actually, technically, I think it'll go up to 4 billion instead of 2.7 because I think they used an unsigned integer for that. They didn't use a signed one because they were like, we don't have negative time. I think. So at least it might be a couple of more years. It'll be in our lifetime though, so we get to see that. But again, it'll be like 2YK, or like, yeah, maybe some things crash, but like you move on the next day, like you just press, you update or something. Anyways, okay, so now that we got this TimeT stuff working, let's go ahead and introduce that here. So we're gonna create a TimeT variable, and we're gonna call it current time, okay? And we'll initialize it when we start the program there, okay? So, or actually, we should probably call this start time, and then make another one that keeps the current time. I actually want to use camel case, okay? So, great. All right. So let us go ahead and create a constructor, okay? So a constructor, as we said, it has to have the same name as the class name. However, you can have more than one constructor. And in fact, we are going to make a version of this, not initially, but maybe like in a little bit here, that has some things that get pre-initialized. But for now, let's just make a default constructor. Now, let me show you a more interesting way. So one way you could do your constructor is you could say, oh, okay, I'm going to pass in like parameters here. Well, you should do that anyway. So like this is going to be the int h for the HP, int, oh, they're all starting with h. So we'll do HP, I guess, and HU for hunger, AL for alive. I'm just trying to keep the variable names short. ST for start time. Oh, actually, no, we don't need that. We don't need to pass a parameter for that, nor for the current time. Yeah, so we just need to pass in those 3 parameters like that, okay? Now, normally, if you're doing your constructors, one of the ways that you can initialize variables is you can go and say like, oh, okay, let me do the HP from here gets the HP from the parameter, right? And this is cool, except that you are going to run into problems with HP specifically because it has the same name as the local parameter. So if you run into a situation like this, how do you clarify to the compiler that this HP is actually this local variable, or sorry, this class variable, and this HP is this parameter variable? So there's a lot of ways to solve this. And I'm already seeing a couple of you suggest one of them. Yes, you can use what's known as a this pointer. We haven't talked about pointers yet, but you know, you can still use it. And as you can see, I am getting here the autofill telling me we have all these variables available to us. I'm curious why it's not showing HP. Maybe because it's already there. That's weird. Why is it not showing HP in here? That's oh, it's because I'm missing a semicolon there. So the autofill wasn't working. Yeah, but you can see that that's one way to do it. So that will work. In fact, let's leave it for that one. An alternative way of doing it is you can use your scope resolution operator. So this guy. So this guy is useful when you're trying to access members of a class. So if you could also write here Tamagotchi, scope resolution operator, and then HP. That's another way of doing it. And you don't have to use pointers for this one. So this is actually, I guess, the recommended way until we learn what pointers do. And then I'll actually spend like half an hour explaining to you what this is actually doing. Like why this works, this pointer thing. Yeah, you could also just literally use a different variable name and avoid this whole confusion, which is what I did with HU. So like, you know, with the, I forgot what the variable name was called. It's hungry. With this hungry, you know, I can actually like say HU like that, and I don't have a problem because I have different variable names, right? So there's a lot of ways that you can solve this, but this is just, I guess, 3 different ways of doing it, okay? However, there's another way that you can solve this, which is really nice for initializing classes. And that is using an initializer list, which is putting a colon there and then saying actually something like HP gets HP, comma, and is alive gets AL, and what's the other one? Is hungry gets HU. I know that one's off screen. Just give me a second. I'm just gonna bring this all down to the next line like that. But yeah, then you resolve all of this stuff. I also saw some people enable variables. Yeah, okay, so I read that. So what is this? Does this let the computer know which one's a local variable? So yeah, like I said, like that's it. We haven't talked about pointers, but in the 5-second answer to your question without explaining pointers, which we will spend like weeks on, is that every object has a reference to itself, and so it remembers. It's like every house has an address like stored in it, so the person that lives there knows where he lives. Like, you know, that might seem kind of redundant, but like imagine like you wake up with amnesia and you're in some place and you're like, where the heck am I? Well, you can just go outside your house and look at the number, right? Well, the number gives you some information, I suppose. I guess it doesn't tell you technically the street, but just imagine that every single house had a plaque with the address, which would be very useful, because if you wake up with amnesia, you're like, who am I? You can just look at the address and be like, okay, at least I know where I'm at. So that's kind of what the this pointer does. And it's very useful when you're trying to access your own variables. Again, that's all I'll say, because we'll spend like considerable amount of time on this when we talk about pointers. But it makes no sense for me to start talking about addresses when we haven't talked about memory in general. So don't worry, we'll come back to that. So I guess the safe version, if you don't want to do this stuff, is you can use this Tamagotchi thing. Okay? And by the way, I guess while we're at it, like this pointer stuff is the same thing as if I put this as well. That is the same thing as this. But yet again, another reason why you don't want to do this, because we haven't talked about that with the dereference operator and the arrow operator and the member access operator, okay? So, but yeah, let's talk about this method, because this is much cooler method and much simpler and faster, and you avoid problems with naming conventions. In this method here, this initializer list is super cool, because all you got to do is put the class variable names here and then put parentheses. So it kind of looks like a function, but it's not a function. All it's saying is whatever you have in here is what you're going to initialize this with. And this is a really, really cool way of initializing variables. And actually, when we talk about inheritance, it's going to help when you're trying to call the constructor of a parent class. So I encourage you to do it this way. I have no idea how the assignment actually makes you do it. I kind of low-key hope it was this way, but it's not. However, this is the superior way, by all means necessary. Like, yeah, all the cool kids are doing it kind of thing. Okay? So anyways, this is great when you are being passing parameters, right? But like I said, we might have a situation where like you just have a default constructor where nothing is being passed in, right? In that case, then yes, you can either set them manually like this or whatever to whatever default values you want, but you can still use this and just hard code it. So you can say like HP gets 0. Actually, let's start with 100 HP. Let's say that the is alive status is true. We'll say 1 for true, and then is hungry is true. Okay, so you can still do it this way as well. All right. So I'll leave all this commented out because, like I said, I am uploading every weekend or every end of the class today. I am uploading the code that I'm writing here, so that you all can download it and play with it and experiment. So do remind me to make sure I save it, not to delete this. I have a folder here. This one. I think this one. Yeah. So I will add it as 04 here. Oh, no, I don't want to zip this. So this will be 04.cdp. So at some point I'll copy it over there, okay? I'll copy the code, okay? So anyways, let's go ahead and initialize the two variables that we do want to initialize like in here. Actually, we could do them technically here, but I'll do those in here as a variation of the example. And that is the current time and the start time. So for that, we're just gonna copy and paste this line of code. Again, I could in theory have done this, like, I could have done like cur time null, but I'm not a fan of putting that complicated code in that like that because it's a little harder to read. But okay, since I did that one already, and now we're gonna leave it. But start time is literally going to be the same thing for now, because start time and cur time are going to be identical the first time you run it. So we'll leave this one inside the code. Okay. I'm curious actually. Let's leave it like that. Because like, no, what I could have done here is just put current time in there. But now I'm curious if like the code, I mean, I assume the numbers will be the same, but who knows? Maybe one will be before the other one, depending on how slow the program runs, you know. Like it might be like a 1 second difference, but I highly doubt it. But in theory, it's possible because the road system calls. And it could be like right at the swap of the second. So this is a great way to get a really bad bug for the game if you end up with start time being after cur time and then like the game crashes. Like I totally see that as a really bad thing to do, but whatever. Okay, let's go ahead and do this. Just do the same thing for this one. I'll put that one off screen, but it's the same thing. I'm just copying and pasting, okay? So, okay. So let's just, before we go any further, let's just make sure that this is working by, for temporarily for now, let's go ahead and make everything public. And by the way, your constructor should always be public. Don't make it private. Bad things will happen. But let's just make sure that since everything's public, let's just make sure that it works, okay? So let's create an object of this class. So let's instantiate the class by creating an object called Tamagotchi. I would like you guys to inaugurate it with a name. So please, for now, we're going to say name pending, but I would like you all to give me a name for this thing. And then we'll put that in. So in the meantime, I'll say name pending. And then let's just see if the time stuff works by just accessing the variables directly. Cur time. I'm actually curious if the times will be the same for both variables or not. If you try to call a private constructor, what would happen? The code won't compile. The code will not compile if you do that. In fact, let's try it. Let's make the default one private and the custom one public. Or actually vice versa, just because less typing. I believe it will give you an error if you try it. So whereas this code should run, let's leave it ready to go, the second version. So the second version, we're gonna make just a 111 for all 3 parameters. But for now, let's comment it out and see what happens. Okay, so this one should run. Wow, crap. Let's see what happened. Type is private within context. I thought I made it public. See, we broke it already. It's already complaining that because this one's private, it's like yelling at me, even though it's beneath it. And then it's also needing this semicolon. That's more important too. Oh, it's because, hold on. That's because when we made that private, we made all the variables private too. So I gotta switch it back to public. So why are you yelling at me with the current time there? I don't know. Let's ignore it. Did you mean C time? Did you mean C time? No, I did not mean C time. Oh, I gotta delete this line. My bad. That was from before when we were doing the example. Okay, so why can't I scroll up? It's not letting me scroll up. Oh, okay, I know why. Because I need to see out the output so I can see what this is even doing. There we go. Okay, so too many arguments. What? I think I broke my terminal. There we go. I don't know what happened there. Okay. We definitely broke something with the time, because we got one of them to be the right time, and then the other one is like in like 1969. Oh yeah, we definitely screwed that up. See, now we've done it. We flipped something upside down because now we're in 69. Okay. What did we break? Time null is TimeT, current time. How did we do that? How did we do that? That is weird. Okay, let's ignore that for a second, but I do want to show you the thing with the private variable. So like, okay, now we're gonna try to actually use the constructor that's private, and let's see what happens. So we get an error, it doesn't compile, and if we show the error, it says that this constructor is private within its context. So as you can see, it will yell at you if you try to create an object and the constructor is private, because it's like, yo, that's private, so I can't call it. So yeah, don't make your constructors private unless you have a very specific reason. If anything, you want to make it protected if you're intending on like inheriting and doing weird things, but never private, okay? So yeah, all right. Let's see, we have a couple of other questions. Will we have to work with the time library in the assignments? I have no clue. I don't know, because I don't know the other assignments yet. But if you do, it's not hard. Literally, you just import it, and now it works. Well, I mean, it works sometimes. As you can see right now, it broke. I'm very curious as to what I did to break it, though. Like, why is one variable good and the other one's not good? That's weird. It's not... I'm not assigning it probably, so current time's the one that's breaking, it seems. Or is it current time? No, it's start time, the one that's breaking. Time, oh, I know why. No, it's not that actually. Okay, here, maybe you guys will see it. I see my problem. And it has to do with copy pasting and why that's a bad thing. Yes, the problem is in start time. The problem is lines 9 and 17. There's something I put there that is screwing it up. I'll tell you what it is if nobody can guess it in the next 10 seconds though. But maybe you will. I mean, this is good. This is good. So like reassigning it. No, that's not. No. You're kind of thinking something right. Kinda. I think you might have the right idea. Yes, defining it twice. I think you're both kind of in the right page. So let me tell you what it is. I am declaring it here. again. So what I'm doing is I'm declaring a local variable that is called start time. And then I'm assigning the time to that. So really, I'm not actually accessing the class variable. I'm declaring a brand new variable. And of course, that brand new variable gets thrown away after the constructor ends. So I gotta get rid of that. So, yep. But it's good to see this kind of mistakes. It makes you think, like, so you don't make the same mistakes that I did, okay? So anyways. Did I misspell it? Start time? Oh yeah, I forgot a T. Start. There we go. Okay. And so now, yes, the time is good. Interestingly enough, even though there's separate calls, they're happening so quickly that it gets the same second. But probably if I run this enough times, I might get a situation where they maybe are different. Maybe. But like it would be very hard. Like, because think about it. Like how many operations the processor can do per second? I would have to do it literally at the switch of the second. So it would be really, really hard. Like maybe if I run this like 50,000 times, I would get one scenario, which you could do. You just write a loop and just run it, you know. But yeah, I'm not looking to doing that. Yeah. So you can put an if statement, like make it loop, make a million different objects and check each one. Maybe we'll do that later. Maybe we'll do that just to catch that. But yeah. Well, there is a command that you can do called time in Linux. So if you write, can't see it. Hold on. There we go. If you write time, and then where am I here? Am I in the same location as the folder? No, I'm not. I don't want to. Do I want to mess with this terminal? Yeah, I'll mess with the terminal. Let me just show you something useful. Oh, what am I doing? Sorry. CD code. CD test. I think this is where in the test one. This is the one we made when we were showing you how to set up the compiler. Okay, so I think let's just do head main to see if this is the code. Head main.cpp. Yeah, okay, so this is the code. So, to compile your code, you do G++ and then you do, in this case, main.cpp. Oh, I know what I did. I switched to Python. I'm in Python. Jeez, what the heck? Okay, that's okay. Don't worry. That's because this is the data analytics class. But yeah, if I compile, if I want to figure out how long a compile takes, write time in front of it like this. And that'll tell you how long it takes to compile your program. User and system time. User time is just wasted time that the system's waiting for you or something, or waiting for something else to happen. So the real time is actually here. That's the real time it takes your computer to do it. So try it at home. And then of course I can also do it on the output to see how long a program takes to run. You can't see it there because it's off screen, but the system says literally 0 because it's so tiny it doesn't even take 0.000 of a second to run it. Okay, it's like it's here. Let me just so you can see that. I'm not lying to you. See that? So yeah, really fast. But yeah, don't need to don't code something that is literally like you can do by just adding time in front of it. I hope I did not break my Python example now. Oh, okay. My Python's code still works for my other class. All right, going back to the right class now. There. That's nice. I'm so lost. What are we doing with the start and the current time? What are we using these for? We're just going to use them because we need to keep track of time, right? So because otherwise, how are we going to know when it's time to feed the Tamagotchi thing? Like, if we make some time variables, then we can say he has to be fed every minute. We can do 8 hours, but I don't want to say 8 hours waiting to test it, right? So what we're going to do is we're going to set like a reminder. So it's going to be running, and then like when it comes time to feed it, it's going to be like, yo, feed me or something. So that's why we're adding this whole time code to it, so that we can actually do that. Anyways, so now that we know that the time stuff is working, we can move on to the actual code. Maybe let's write a class that gets us the time, and then we'll move on. Okay, so let's just do one. Sorry, not a class, sorry, a function, just a function. Okay, so we're gonna make a public function, and that function is going to be called get time, get current time. All right, and it's gonna be a void function. And it's going to just return what we were writing earlier here. In fact, this should really be called print current time. Since I mean, I could return it, but then I have to see out it. So let's just see out it in the function itself. Like that, okay? And then now we can just get rid of all of this stuff from here. This I don't want to get rid of because I want to leave it for you guys. So I'll leave it down there for now. But I just want, so, you know, I want to make the code as compressed as possible. You probably have to make a new class for time and just create a time object with Tamagotchi, right? So if I was doing good coding practice, then yes, that would definitely be the better way to do it. You would keep all the time stuff in its own class. And we might do that actually. We should totally do that as an upgrade later on when we talk about inheritance and composition. We will go back and upgrade our Tamagotchi. And then, you know, by the time that we finish all those examples, it'll be much cooler. So, yep. You have defined what the class example will be for the next few semesters. By the way, did anybody ever pick a name for the Tamagotchi? Are we doing it the Yandere? Is that what you all said? Is that going to be the thing? Okay. Yeah, lowercase y though. But yeah. All right. So, okay, so now we have a print current time. Let us do the same function, but for start time, in case we want to use that or see that. We don't actually need to put name pending in here. We just need to do that. And I think this should be good to go. Where are we forgetting a semicolon? Here. Okay. So, yep, code compiles. All right. So now that we've handled the time, we'll go back to it. But anyways, it's running, it's working, we can move on, right? And this is a good strategy when you're trying to do your program, right? Code a function, test it, make sure that piece of code is working, move on to the next. Don't try to code 50 different things and then like try to compile your code after an hour of coding and then like see like a million different errors. It's better to go piece by piece. It's easier that way. You don't get overwhelmed by all the error messages and whatnot. Obviously, as you become better, you know, you can code a lot longer without getting 50 different error messages. But you know, at the beginning, it's a good approach. Okay. So, all right. So let's go ahead and see what we need to do. So we need to do the HP. We need to do the feed is alive, get time, and get HP function. Okay. So let's do the get HP function because that one's easy to do. So for that one, I'm not going to do it so what I'm doing here is kind of like an inline declaration style, but I want to show you some examples of where you're not declaring, where you're declaring the function in the class, but you're not defining its contents there, okay? So if you do that, you just need to put it like kind of like a prototype. So you say something like get HP, and then the parameter, which is going to be actually no, nothing for this one. It just, and then it returns an int, sorry. So I saw them flipped over here. So it'll be just int get HP, okay? So let's go ahead and actually define that function outside of the class. So the way you do that is you use the scope resolution operator. So you write the name of the class, your scope resolution, just like we were doing earlier with the constructor stuff here. And then you write the name of the function and make sure you put the return type. So this is void. And then you can actually write your code, which is ironically going to be as simple as return, or sorry, not void, sorry, integer, not void. It's going to be just literally like return, what is it? Return HP, probably. Yep, that's pretty straightforward. Yeah, okay, cool. I thought it was a new message. Okay, so that is how you would do a function that's not defined in your class. Okay, so you would write like a prototype up here. So where is I lost it here? You write a prototype here, and then when you're defining it, you know, if you do something like this, get HP, like that, that's just a global function. So that's why you gotta put this part. This is the important part of the test. This is not a global function. This function belongs to a certain class. And technically, the colons are called scope resolution operators. So if you know what namespaces are, you actually would do the same thing for a namespace. But again, namespaces is not on the list of things to teach. So yeah, you just kind of learn on your own. But yeah, don't worry about it. It's not important. Okay, so Yeah, let's go ahead and do another one. So let's do the so let me check them off so we know what we did. So this one's done, and all this stuff is done. I think we did that. Yeah, we did that. Oh, we never finished the constructor. I think we gotta finish the constructor. It is taking way too long to color this. I should have done a bigger thing. Okay. But it's gonna bother me if I don't finish it now. Okay. All right. Let's finish the constructor. For this one, we did finish it, but for this one, we hard coded is alive. Oh no, we did finish it. We said this is true. Oh no, so it is finished. Never mind. We're good to go. Okay. Then we. And by the way, you should probably put your constructor in your UML. I didn't necessarily because I wasn't putting all the functions. But if you did that, you could do something like Tamagotchi, and then that's it. You wouldn't put anything on that side because it's a constructor. The other constructor, you would do Tamagotchi int boo. Oh, that's a good point. Did we say integer or boolean for the parameters? Yeah, that's very inefficient. Although I think the compiler will turn it into an integer anyways. Let's be good about it and actually use booleans for that, because they're booleans. So like, the compiler typically turns a boolean into an integer. Like, it uses the same amount of space, 4 bytes. But let's be correct and use bool there instead of int. So and I mean here, I don't think that C++ has true and false enabled, but maybe it does, and I just don't remember. Oh, it does. Okay, so it's C. C is the one that does not have booleans by default. So if you're coding in C, you actually have to include the boolean library to be able to use the keywords true and false. And C++, it's I guess part of the standard stuff. So you're good to go. Okay, so great. Okay, let's do the rest of these functions then. I'm just gonna kind of work with them faster. So let's do them all outside, because like this is already getting way too big. In fact, you know what? Let's move this constructor. Oh no, because I can't move it outside because I leave this. No, let's leave that as it is. Let's just write the rest of the prototypes and then define them outside. Okay. So we have the void for the update HP, and then we have bool for is hungry. And then we have is alive. And then get the time. Do we really need that? Sure, I'll add it anyways. Why not? So the TimeT get time. We gotta pick a time though. So maybe what we're gonna pass there is an integer that defines whether it's current time or start time. Okay. Although I don't like that as a thing, we'll just let it be. It's a good example of something with a parameter. I think that's all the functions that we have listed so far. Feed. Oh, we have feed in there. Okay. So now let's go ahead and define all of these functions. And that's what you would do when you're in like the header versus the CPP file, etc. Okay. So let us add Tamagotchi to all of them. And then let's add a parameter for that. So we'll call that age. And then this will be type of time. So we'll use a T for that. And then do that for all of them. There's like Visual Studio shortcuts to do all of this, but I don't remember them. So you could like not have to copy paste and manipulate. What's a good rule to know whether to write a member function inside a class or outside with the scope resolution? Well, they do the same thing. So in my personal like decision, if it's like a one-line function, I'd actually write it in the class because like you can just get it done quickly. If it's a function that's going to take more than like 2 or 3 lines, then you definitely want to put it outside, because otherwise you clutter your class definition. Your class definition should be very small so that you can read it quickly, and like if like somebody's using your code and they want to see what functions are available to them and they decide to look at the header file, you know, they want to just see the function names. They don't care how they're defined. So you ideally just want to keep the function names in there. The constructor is like the one exception for efficiency, because technically it's more efficient when you actually put code in the class definition. Like internally, they become like inline functions versus like a real function. So it's actually a little bit more efficient, but sometimes efficiency is not everything. You want to make your code readable. So that's the long answer to that. Could we use a line using namespace Tamagotchi? Yeah, we could if we created a namespace for Tamagotchi, but like I said, that's not really part of the class, so I don't really go over namespaces. But you can like Google Geeks for Geeks namespaces, and they have examples. They're trivial to do. You just use curly braces and like declare your namespace, and bam, a lot. You created like a namespace or something. So yeah, okay. Let us go ahead and finish these functions though. Update HP is literally just going to be, well, actually, you know, this is a good thing. We could just do this, but I actually want to make sure that they don't. Oh wait, update HP is a private function, so I'm glad I caught that. Let's make that a private function. And let's make all our variables private now, since we don't need to make them public anymore. So let us take update HP and put it down here. And even though it's private, I'm still going to do some checks. So I'm going to say if h is less than 0, then just set it to 0. Okay? Otherwise, if h is greater than 100, oh sorry, this is Python with the colon. My apologies. It's not in C++. You do that. If h is greater than 100, then oh, what am I doing? Put 0 here. If HP is greater than 100, then you just set it to 100. Otherwise, else, which you don't really need it, so I'm just not going to put it. You're going to put HP gets. Oh no, you need it actually. HP gets H. Okay. So there you go. Now, because this is how you would do it, but because I'm trying to keep the code as like short as possible, because we have such tiny space in the screen, I'm gonna make it like that. Okay. So yeah. In fact, you could even make it like that. There you go. Okay. But yeah. So basically, what we're doing here is we're sanitizing our input. That's called sanitizing. So it's a good thing to always do. That's how you avoid getting hacked and things like that. Obviously, this is oversimplification of that. But, you know, we're saying that even if we get a number that's wrong, we get somebody that says like, oh, update it to 200. Yeah, no, it's 0 to 100. If you somehow get a negative HP, you make it a 0 HP. Okay? Furthermore, I would like to add something else in here. If after the update, HP is 0 or less than 0, I would like to change the status of the live thing to be dead, right? So maybe we say it's alive, gets set to false. So we kill it, you know, kill the thing. All right. So yeah, that's a good thing to have in there, okay? But it's only if the HP goes less than 0. If it doesn't, then it'll be alive. It would live to die another day. Okay, is hungry? That one you don't need to do any sort of real testing, because it's just going to return the value. So literally just do return is hungry. So this is like an example of a function that I actually would write in the class definition. But I'm trying to show you both examples. Same thing with this one. Is alive. And then get time is just going to return the TimeT variable. We said we're going to decide. So let's say if t is equal to 0, then actually, again, I want to save space. So I'll just do it here. Return start time. Otherwise, return current time. So we'll say we're kind of making a function that can do two things at once. So we're saying if the parameter here, if they say something like get time 0, that's the start time. Otherwise, if they say like, you know, if they say get time 1 or whatever else, that's the current time. So I'm just trying to make it to, that's something you would want to put in your documentation, by the way. Could you shorthand line 55 to if not T? You know, I was thinking about that, but yeah, I don't know. This is like, what if they put a negative number, do weird things? Like, that would work too, actually, with negative. So you could, you know, but you know, I kind of felt weird about that because it's not a Boolean, it's an integer, and like, I don't want to break things, so better safe than sorry. You know, what you don't want to do is say something like, if you are dealing with a Boolean and you say like, if some bool is equal to true, you know, that's one way to get laughed at. You know, if you do that, don't do that. You know, you just do like, if some bool, right? You know, so I don't encourage cyberbullying, but don't do that, you know, don't do that to avoid getting cyberbullied by people who look at your code. Like the Yandere dev, I think he put that in there in his code. He had somewhere in the code. I saw a video and it's like, yeah, he put like if something equal to true, and that's why people made fun of him. So there you go. So yeah. Okay, so the feed one is going to basically cancel the fact that he's hungry, right? So we basically want to say is hungry becomes false, right? Because you're feeding him. Okay, so all the code works. Well, actually, no, it does not until I test it. See, it did not all work. Because we probably got to figure out a bunch of things here. So let's see what we need to fix. Oh gosh, why is it? We're probably missing a semicolon somewhere and it's really pissed off at us. Let's see, why is it complaining about all these things? Using namespace std, class Tamagotchi, public Tamagotchi, blah, blah, blah. Okay, I do not like VS Code's errors because they're useless to me. Let me compile it on my own and see. Oh, here, we can compile it here, actually, since we had this set up. No such file exists. Oh, it switched back already to the other one, that's why. Let's open up I think we have a terminal already open for this. Yeah, no, that's a Python one. See this one. This one. Yeah, this one's good to go. Let's try this one. So, G++ main.cpp. Okay, so let's see what the errors say at the top. Always start at the top. Conflicts with the previous declaration. Okay, this tells me more. This tells me that there is an issue between line 36 and line 26. Oh, I see what it is. Yeah, it is. You're right. It is because of that. It's we should not have picked the same name for the function than the class variable. So, yep, it's like, nope, you are not allowed to do that. So we got to change one of them. So which one do we change? Hey, let's just make it up lowercase. Problem solved. No, because hunger level kind of tells me that it's a level, and really here it's a status. If anything, hunger status would be better. But yeah, we'll just change the functions and leave those as they are. Because otherwise you have to change like 40 different places at once. So we're gonna change this to be hunger status. Or actually, you know what is nicer? RB hungry. Oh no, that's too long. Hunger stat. Let's just hunger stat. Alive stat. And then make sure you also update the prototype. like that. See, I could do underscores, but the thing with the underscores is that I'm trying to avoid them and use camel case because that will make the names even longer. Okay, so now we're okay at least. You know, better names could be chosen here, but it is what it is, right? Okay, so I mean, it works. Everything works, but it's not really exciting, right? We need to like give it life. So how do we give it life? Let's think about how we're going to do this. We're going to put this in an infinite loop, and then we're going to say that every X amount of seconds, the thing is going to go hungry. Okay? So the way most games do this is they have like an update function. Now you shouldn't be putting everything in your update function. Yet again, another thing from the Gendera dev. But we're going to do that just because I don't want to have to make 50 different functions. Okay? So it's one of those like don't try at home kids kind of thing. Okay? So we are going to create an update function. And this function is going to run every frame or every iteration of the for loop. Okay? So this is going to be like the function of the game here. Okay. Underscore looks nicer than camel case. Personal preference thing. So I like camel case more. Underscore's too far away for me to press. Like I gotta actually try use both hands in synchrony. So okay. So our update function is going to basically check. Let's say. Okay. So. Maybe like a 30-second timer, so that it's long enough that we can see it happen, but not so crazy just spams us. So what we'll say is this: let's write this logic down properly, because we don't have to code this 50 times. So the way the game's gonna work is, every 30 seconds feed. If not, you get -1 HP per second. Okay, so we'll do that till death. Okay? And maybe we'll implement the sleeping and everything else after. But let's just do that. Let's do that every 30-second thing. And also write message, write message of starvation or something. So we know where the thing is dying. Okay? So yeah, we'll do that. So every 30 seconds from last fed time. So actually that's a good point. We need another variable that keeps track of when it was last fed. Okay? So yeah, let's do that. So let's create another time variable called last fed. So TimeT last fed. And then we are going to go ahead and add that to our constructors. So for now, the last fed time is just going to be the time that we create the program. You can't see this one, but I'll bring it down in a second. There we go. Wouldn't it be easier if you said is hungry true then -1 HP per second? Yeah, we can do that. We can probably do that. Okay, so now that we have our last fed and it's initialized, our update function is going to check. So we said if, first of all, yeah, let's do the decrease of HP if it's hungry. So if is hungry, oh, oops, Tamagotchi, okay, there we go. If, I guess technically we'd access the variable directly, but I'm gonna do it with a function because it's nicer. It's the object-oriented way. So if hunger stat, see, it doesn't sound as cool now than it's hungry. That's very sad, very, very sad, but okay. If hunger stat, I don't like the sound of that. I have an idea. Let's use I'm hungry. Again, you want to write code that's self-documenting, meaning that you don't need to write a comment because it's so obvious based on your code. Not just to you, but to the world, okay? I'm hungry. Here we go. Hopefully, yeah, I'm trying to get this code as fast as possible before the time expires. Because I want to show you that if this runs, and then we can pick up where we left off next time. Like I said, I expected us to basically code all day today, which is good. Because again, last time we got no code. Okay, so now I can say I'm hungry. I think. If I'm hungry, then we have an update HP, right? Update HP -1. I think that'll work. I think that's how we coded the update HP function. It just takes a number. Let me find it. Yep. So, oh wait, no. Oh no. The update HP just like changes the HP to that value. So we might want to make another function that decreases the HP. You know, so that would be much nicer. In fact, let's. Okay, we should do that, but we won't do it this time. Okay. For this time, we are just going to take the current HP -1, okay? We really should be doing a decrease HP to be truly object-oriented, but we'll do that next time because we got like 2 minutes left, okay? So we'll say if I'm hungry HP, how are we going to feed it? We need to like, we need to query the user for input, right, to feed it. So let's just say let's just do a cnx just really fast, and then if x is equal to 1, that means you feed it. So feeding me. So then we will call the feed function, okay? Now the feed function, we're going to add another thing here. We're going to remember when it was last fed. So we want to update last fed with current time, which we need to call again. So it's time null, I think, right? That's what we said it was, time null. Time null. And then to find, we also need to update the hunger variable. So we need to check if 30 seconds have passed from the last time it was fed. Again, this will be its own function, but we'll put it in here really fast. So we can say like if we need to get current time. So let's update current time. In fact, that should be one of the first things that we should do in here. So we should say current time gets time null. And then we can say if cur time, I hope it lets me do this, minus last, wait, that goes up, yeah, okay, this will be okay. If cur time minus last fed is greater than 30, then we want to set the hunger variable to true. Again, we'll change this later and make it cleaner next time, okay? Because really we should be using functions for this. But I really wanted to show you this, but I don't know if we have enough time. The time has come. See if it compiles. Okay, we should probably be using a bunch of semicolons. Yep. Okay, it works. So let me just run this in the loop and see if it works. So for int I is equal to, let's just say I is less than 60 turns, I++, and then call update. Okay, so if we run, come on, semicolon, we run it. Oh, Tamagotchi update. So yandere dev dot update. Yes, this is what I meant. Okay, so it's running now. So because we don't have a synchronous input, which I could show you sometime, you know, let's just enter a 0 a couple of times. Oh, well, we don't even, damn it. It's working, but we don't have a message saying it's hungry. So let me see out hungry or something. Okay, so let me just stop it and run it again. Also, let us increase this to 10 seconds. Decrease it to 10 seconds, just so we can see it before the time expires, okay? So it's hungry right now already. That's cool. Oh, God. It's because of this. Okay, so if we feed it by putting in a 1 in there, then it shouldn't be hungry anymore. However, if we wait 10 seconds, hopefully we will see I'm hungry pop up again. There we go, finally it popped up. See that? 10 seconds pass, it's hungry again. So if I don't feed it, it's still hungry. If I pass a 1, it's fed. So now it will not show you anything until 10 seconds go by. So we're waiting. And the program died because, oh, we went past the 60-minute marker. But there you go, you got to see a quick example of it. So we'll actually clean this up and make it nice next time. But I wanted to really show you like something before the end of the class, you know, after we've been working all class for it, to see some output of our work. So yeah, I will upload this code to Canvas, like I said, at the end of the class, which is now, but give me like some time. But yep, okay. So anyways, to summarize what we did today is we basically showed you how to write a class. We wrote some functions, we wrote some constructors, we wrote things outside of a class and inside the class, different ways of initializing values in the constructor, the this pointer a little bit, scope precision operator, and even the time class, okay? Next time, we will continue expanding this class by writing a lot more functions. Maybe, no guarantees, we will do something asynchronously. Otherwise, you have to keep pressing 0 to refresh the timer. But yeah, like I said, hopefully you got to see some nice code, and I encourage you to play around with this over the weekend after you finish your assignment, because you want to do that too, right? But at least now you should have good foundations to do your assignment as well. So again, thank you for your patience. Hope that you learned a lot, and yeah, that's all. So wishing you all a good day. If you have any questions, just message me or email me over the weekend, and I'll get back to you as soon as I can. All right? Remember, Monday is off, Labor Day, so there's no class. Don't show up on WebEx or nothing. And next class will be on Twitch. All right? Thank you. Have a good night, everybody.